Okay, so this is the last part of chapter 8. It's section 8.5, testing independent samples. We're going to identify independent samples and sampling distributions. The test, compute the sample test statistic and p-value for mu sub 1 minus mu sub 2 and conclude. Compute the sample test statistic and p-value for p sub 1 minus p sub 2 and then make your conclusions. All right, independent samples. You guys can read that. You should remember what independent samples are at this point. This is your second round dealing with them with the application. And before that, we also dealt with dependent and independent variables. So you should be totally fine on just reviewing this for yourself. All right, first let's consider independent samples. We say that two sampling distributions are independent if there is no relationship whatsoever between specific values of their two distributions. Example 11. A teacher wishes to compare the effectiveness of two teaching methods. Students are randomly divided into two groups. The first group is taught by method 1 and the second group is taught by method 2. So like an example of this could be in person versus online. Asynchronous versus synchronous learning, group versus individual. There's a whole bunch of different things you could do with this scenario. At the end of the course, a comprehensive exam is given to all students, and the mean score x bar sub 1 for group 1 is compared with the mean score x bar sub 2 for group 2. Are the samples independent or dependent? Okay, because the students were randomly divided into the two groups, it is reasonable to say that x sub 1 bar distribution is independent of the x sub 2 bar distribution. All right. We have considered a situation in which a shoe manufacturer claimed that the general public for population of adults in the US has an average length of the left foot is longer than the right foot. All right. To study this claim, the manufacturer gathers data in this fashion. 60 adult US citizens are drawn at random, and of these 60 people, both their left and right feet are measured. Let x bar sub 1 be the mean length of the left feet and x bar sub 2 be the mean length of the right feet. Are the two distributions independent for this method of collecting data? In this method, there is only one random sample of people drawn, and both the left and right feet are measured from the sample. The length of the person's left foot is usually related to the length of the person's right foot. So in this case, the distributions are not independent. In fact, we compare the data and consider the distribution of the differences, left foot minus right foot. Then we could use the techniques of the paired difference test. All right, part 1. This is where mu sub 1 minus mu sub 2 is tested when sigma 1 or sigma 2 are known, and sigma 2 are known. In this part, we will use distributions that arise from a difference of means from independent samples. How do we obtain such distributions? If we have two statistical variables, x1 and x2, each of its own distribution, we take independent random samples of n1 from x sub 1 bar distribution and the size of n2 from x bar 2. Then we compute the respective means, x bar 1, x bar 2, consider the difference, and then this represents the difference of the means. This should all be pretty similar to you. The only difference here is that we're using bars. Fortunately, it is not necessary to carry out this lengthy process for each example. The results have already been worked out mathematically. The next theorem represents the main results. All right, so this is your procedure. Go ahead and write it down. There are your requirements. Make sure you pause the video, take all your notes down. Okay. There's the second part of your procedure. Again, I recommend pausing the video and writing it down. All right. Example 13. A consumer group is testing camp stoves. To test the heating capacity of a stove, it measures the time required to bring 2 quarts of water from 50 degrees Fahrenheit to boiling at sea level. 2 competing models are under consideration. 10 stoves of the first model and 12 stoves of the second model are tested. The following results are obtained. Okay, so we're going to use these to help us figure out our test. Assume that the time required to bring the water to a boil is normally distributed for each stove. Is there any difference either way between the performances of these two models? Use a 5% level of significance. So that means your alpha is going to be 0.05. State the null and alternate hypothesis and note the value of alpha. So let mu sub 2 and mu sub 1 be the means of the distributions of times for models 1 and 2 respectively. We set the null hypothesis to state that there is no difference. So the null is going to be mu sub 1 is equal to mu sub 2, or mu sub 1 minus mu sub 2 is equal to 0. The alternate states that there is a difference. So mu sub 1 is not equal to mu sub 2, or mu sub 1 minus mu sub 2 is not equal to 0. And the level of significance, of course, is alpha equal to 0.05. You have to check your requirements. And then we're going to compute the differences. We are given the values. You should know them all from the other slide. Okay. So we plug everything in and we find a z-score of 1.28. So then we're going to find the p-value. So when we conclude the test, we know that the p-value is 0.2006 and the alpha is 0.05. Since the p-value is greater than alpha, do not reject the hypothesis, the null hypothesis. All right, and if we interpret the results at the 5% level of significance, the sample data do not indicate any difference in the population mean times for boiling water for the 2 stove models. All right, part 2. This is where the sigmas are going to be unknown. To test the difference when the sigmas are unknown, we use distribution methods for estimating mu sub 2 minus, or mu sub 1 minus mu sub 2. In particular, if the 2 distributions are normal or approximately mound-shaped, or if the sample sizes are large, we will use the student's t distribution. Let's summarize the method for testing the difference. That requirement top line says obtain 2 independent random samples from populations 1 and 2 where? So that's probably in your textbook if you don't want to write it from off the slide, but that is what that says. Okay. Like I said, go ahead and pause the slide or pause the video. You can write down the slide in your own words. Here's the rest of it. Please let me know if you end up having any questions. Okay. Example 14. 2 competing headache remedies claim to give fast-acting relief. An experiment was performed to compare the mean lengths of time required for bodily absorption of brand A and brand B headache remedies. 12 people were randomly selected and given an oral dosage of brand A. Another 12 were randomly selected and given an equal dosage of brand B. The lengths of time in minutes for the drugs to reach a specified level in the blood were recorded. The mean, standard deviations, and sizes of the 2 samples are follow. Past experience with drug composition of the 2 remedies permits researchers to assume that that both distributions are approximately normal. Let us use a 5% level of significance to test the claim that there is no difference between the two brands in the mean time required for bodily absorption. Also find or estimate the p-value of the sample test statistic. Alpha is equal to 0.05. The null hypothesis is equal or equal to 0. And since we have no prior knowledge of which brand is faster, the alternate is going to be not equal to and not equal to 0. Check the requirements. Note that both sample sizes are 12, so degrees of freedom can be computed also by the approach. So the t-distribution is appropriate. Compute the sample statistic. Basically find your t-values. Okay, so for the combo, we get 0.875. Here's your diagram. And here you can find your interval is between 0.69, or sorry, between 0.697 and 1.214. So your p-value is going to be between 0.250 and 0.500, which is above. So the p-value lies above your alpha. So we failed to reject the null hypothesis. Using the raw data, a calculator approximation for the degrees of freedom is roughly 21.53, and the p-value is roughly 0.3915. This value is in the interval we computed. So what does this mean? At the 5% level of significance, there is insufficient evidence to conclude that there is a difference in mean times for the remedies to reach the specified level in the bloodstream. All right, part 3. Testing a difference of proportions. Suppose we have two independent binomial experiments, that is, outcomes from one binomial experiment are in no way paired with the outcomes of the other. We use the notation. You guys can read all that and take notes on it. Go ahead and pause it and do so. For large values of n, you have to do the following. Again, pause the video and take your notes. For the most practical problems involving a comparison of two binomial populations, the experimenters will test the null hypothesis as equal. Consequently, this is the type of test we shall consider. Since the values of p sub 1 and p sub 2 are unknown, and since specific values are not assumed under the null hypothesis, the best estimate for the common value is the total number of successes divided by the total number of trials, which is how we used it before, so you should be used to that. If we denote the pooled estimate of proportion as p bar, then you get the following. Again, this should be kind of a review for you because you used this last time. All right, here's your procedure. Go ahead and pause and take it down. Same thing with this one. Finish it up. All right, example 15, testing the difference of proportions. The Mysick County Clerk wishes to improve voter registration. One method under consideration is to send reminders in the mail to all citizens in the county who are eligible to register. As part of a pilot study to determine if this method will actually improve their voter registration, a random sample of 1,250 potential voters was taken. Then this sample was randomly divided into two groups. Group 1, there were 625 people in this group. No reminders to register were sent to them. The number of potential voters for this group who registered was 295. For group 2, this group contained 625 people. Reminders were sent into the mail to each member in the group, and the number who registered to vote were 350. The county clerk claims that the proportion of people who registered was significantly greater in group 2. On the basis of this claim, the clerk recommends that the project be funded for the entire population of the county. Use an alpha of 5% or 0.05 for significance to test the claim that the proportion of potential voters who registered was greater in group 2, that group that received the reminders. Note that alpha is 0.05. Let P sub 1 be the proportion of voters from group 1, and P sub 2 be the group from group 2. The null hypothesis is that there is no difference in the proportions. So they're going to be equal, or P sub 1 minus P sub 2 equals 0. The alternate, of course, being that P sub 1 would be less than P sub 2, or that P sub 1 minus P sub 2 will be less than 0. All right, that's a little bit blurry to read, but that is, again, your R sub 1 plus R sub 2 over N sub 1 plus N sub 2. Plug everything in, and you get a P hat, or sorry, not a P hat, a P bar of 0.516. So then Q bar will be 0.484. Check your requirements. Find your P hat. Okay, everything there, you got that. We computed the pooled estimate for P hat and Q hat in part B. Using these values, we find the sample test statistic. So there's your Z. And you get roughly negative 3.11. Find the p-value and sketch the area on the standard normal curve. Figure 8.2 shows the p-value. This is a left-tailed test, so the p-value is the area to the left of negative 3.11 using the standard normal distribution. Table 5 of Appendix 2. We find the p-value equal to be roughly 0.0009. Conclusion. Since the p-value is 0.0009, which is less than or equal to 0.05 for alpha, we reject the null. What does this mean? At the 5% level of significance, the data indicate that the population proportion of the potential voters who registered was greater in group 2, the group that received the reminders. All right, part 4. Testing the differences using critical regions. For a fixed preset level of significance alpha, the p-value method of testing is logically equivalent to the critical region method of testing. So the book emphasizes the p-value method because of its great popularity and because it's readily compatible with most computer software. However, for completeness, we will provide an optional example utilizing the critical region method. Recall that the critical region method and the p-value method of testing share a number of steps. Both methods use the same null and alternate hypothesis, the same sample test statistic, and the same sampling distribution for the test statistic. However, instead of computing the p-value and comparing it to the level of significance alpha, the critical region method compares the sample test statistic to a critical value from the sampling distribution that is based on alpha and the alternate hypothesis left, right, or two-tailed. Go ahead and pause the video so you can write the test conclusions on critical values statements up there. Critical values Z sub 0 for tests using the standard normal distribution can be found in table 5C of Appendix 2. Critical values T sub 0 for tests using T distribution are found in table 6 of Appendix 2. Again, I highly recommend you either print those out or print out your own copies from Google or save them or something. Use the row headed by the appropriate degrees of freedom and the column that includes the value of alpha level of significance in a one-tailed or two-tailed area. Use the critical region method to solve the application in example 14. Okay. Here they give you everything back again for this bloodstream headache remedies example. And we're going to use the t-distribution. To use the critical region method, you have to find the following. Okay. So you find t equal to 0.875. Instead of finding the p-value for the sample test statistic using alpha and h1 to find the critical values table in table 6 of appendix 2. So we have degrees of freedom equal to 11 since both sample sizes were 12. We have an alpha 0.05. So we find critical values are plus or minus 2.201. Next, compare it to the test statistic to the critical values. So here you can see t is equal to 0.875. It falls in between the two. We see that the sample test statistic falls in the do not reject the null region. At the 5% level of significance, sample evidence does not show a difference in the time for the drugs to reach the bloodstream. The result is consistent with the result obtained in the p-value method of example 14. All right, if you guys have any questions on this, please reach out. Other than that, good luck on doing your homework and your quiz for chapter 8. And I will see you on Wednesday for a brief pop-in, and then again on Monday for the chapter 9 sections. All right, have a great week.